reverberation. Reflection ਇੱਥੇ ਵੀ ਹੈ, reflection ਇੱਥੇ ਵੀ ਹੈ, ਪਰ here you see the sound goes and comes back in just 0.28 second. Here it takes a larger time. So, in the upper part you see what is called reverberation, in the lower part you see what is called echo. So, a reverberation is perceived when reflected sound waves reach your ear in less than 0.1 second. Since the original sound wave is still held in memory, there is no time delay between the perception of the reflected sound wave and the original sound waves. The two sound waves tend to combine as one very prolonged sound wave. If you ever sung in the shower, then you have probably experienced a reverberation. The sound which you hear is the result of reflection of the sounds you create combining with the original sound. Because the shower walls are typically less than 17 meters away, these reflected sound waves combine with your original sound waves to create a prolonged sound. There are three characteristics of musical sound: loudness, pitch and quality. By loudness, we mean the sensation of hearing that enables to distinguish between a loud and a faint sound. It is a subjective term, it cannot be measured physically, because the same sound may appear to be loud to one person and the same sound may appear to be faint to the another person, but it is related to intensity of sound. And what do we mean by intensity? You see, intensity is the amount of sound energy that crosses a unit area per unit time, the area being held perpendicular to the direction of propagation of sound waves. SI unit of intensity is watt per meter square. What we mean by threshold of hearing is the lowest intensity of sound that can be perceived by a normal human ear. That is called threshold of hearing. घट तो घट कितनी intensity दी sound सुन सकता है normal human being. If you denote it by I naught, then threshold of hearing, the value of that is around 10 to the power minus 12 watt per meter square. According to Weber-Fechner law, loudness is directly proportional to the logarithm of intensity. Suppose loudness is L for intensity I and loudness is L naught for intensity I naught. L is proportional to log to the base 10 I. You can write it as L equal to some constant K, this is the proportionality constant, into log 10 I, and L naught as K log I naught. Then intensity level is the difference in loudness, L minus L naught. So, you get the formula as log I by I naught. If intensity is 10 times the threshold intensity, then you see L becomes equal to 1. This is called 1 bell. This is the unit of intensity level. So, the unit of intensity level is bell. How do we define it? We say that the loudness of sound is said to be 1 bell if its intensity is 10 times that of the threshold of hearing. Threshold of hearing कितना सी 10 to the power minus 12 Weber per meter square. Generally, we use a smaller unit which we call as decibel. 1 decibel is 1/10 of a bell. So, if you want to write down loudness level in terms of decibels, your equation becomes 10 log I by I naught. These are some of the relative intensities: 120 decibel jet taking off, 110 very loud amplified music, heavy traffic around 80, and breathing it is very small 10 decibel. These are the pictures showing different decibels of sound. We see aeroplane around 140 decibels and so on. Now, intensity depends upon amplitude, area, distance, frequency. So, intensity is directly proportional to square of the amplitude, directly proportional to area, inversely proportional to square of the distance. It also depends upon frequency. It is directly proportional to scale of the frequency of vibration of the sounding body, then density of the medium through which the sound travels, presence of other sound bodies and motion of the medium. Pitch is that characteristic of musical sound which helps the listener to distinguish between a shrill note from a grave note. ਪਤਲੀ ਔਰ ਮੋਟੀ ਆਵਾਜ਼ ਦੇ ਵਿੱਚ ਜੋ ਡਿਫਰੈਂਸ ਦੱਸਦਾ ਹੈ ਕਰੈਕਟਰਿਸਟਿਕ, ਉਸ ਨੂੰ ਅਸੀਂ ਪਿਚ ਬੋਲਦੇ ਹਾਂ। The frequency of a shriller sound is greater, so it is of greater pitch. The frequency of a flat note is low, so it is of low pitch. This signifies that pitch of a sound depends upon frequency of sound. You can easily distinguish between the voice of a girl and that of a boy. Voice of girl is shriller as compared to that of boy. This means pitch of a girl is higher than that of a boy. Quality is one characteristic that distinguishes between two sounds which have same pitch and loudness. It depends upon overtones or number of harmonics. It is because of quality that you can distinguish between different musical instruments in an orchestra. Now, what is an auditorium? You might have seen an auditorium. It includes any room intended for listening to music, including theaters, churches, music halls, classrooms and meeting halls. The design of various types of auditoriums has become a complex problem nowadays, because in addition to its various sometimes conflicting aesthetics, functional, technical, artistic and economical requirement, an auditorium has to accommodate an unprecedented large audience. These are nowadays being used as the multi-purpose rooms in almost every field, starting from schools to official buildings. So, hearing conditions in any auditorium are considerably affected by purely architectural considerations like shape, dimensions and volume, layout of boundary surfaces, seating arrangements, audience capacity, surface treatment and materials used for interior decoration. Seeing to the increasing use of auditoriums in the present scenario, the study of acoustical concepts in auditorium design is a necessity. There are many factors like loudness, focusing, echelon effect, extraneous noise, resonant etc. that affect the acoustics of a room or a hall. The speech or music that is produced in the hall should be sufficiently loud so that it is clearly heard by the audience to ensure uniform distribution of sound intensity in the hall. So, we use electrically amplified loudspeakers so as to make it sufficiently loud. Low artificial ceiling should be provided as it improves the audibility. The hall should be preferably rectangular in shape. The hall should not have seats near the walls and a passage must be left between the walls and also in between the quadrants of seats. Now, if you take the case of reflections, some reflections they can be multiple and frequent in a room with few absorptive material. So, if you have a room where absorption material is lesser, then the sound may concentrate to one point. The simplest form occurs is when you see these sound waves, they are striking the flat surfaces. So, these are the reflections that are coming to the audience. If the audience is sitting near, this is reflective near the speaker, absorption is shown to be in the rear end. Now, these sound waves that are reflected, they may get focused to a particular place. So, this focusing of sound, it should be avoided, because the observer here is receiving the sound directly as well as after reflection. So, there may be constructive interference, there may be destructive interference. So, destructive interference should be avoided, otherwise it will give rise to what is called silence zones. Echelon effect is due to the presence of a regular structure such as a flight of stairs. If there are stairs inside the room, you will observe echelon effect. When sound is produced in front of such a structure, it produces a note because of successive echoes, and then it will reach to the observer. To prevent this, the staircase should be covered with carpet so that no reflections are produced. Then there is extraneous sound, undesirable sound that may be airborne or structure borne. The sound that reaches the hall from outside is what is called airborne sound. You cannot completely eliminate this, but one can minimize this by using double or triple windows and doors. The sound that is produced by, say for example, fans attached inside the hall is called structure borne sound. It can be minimized by paying proper attention to maximum permissible speed of fans and the rate of air circulation in the room. The air conditioning pipes must be covered and acoustically insulated from the main building. So, a part of it directly enters the hall through the open windows. This is airborne noise. You can locate the building on quiet sites away from heavy traffic, or they may be shaded from noise by interposing a buffer zone of trees, gardens, etc. to avoid airborne sound. One can get remedied from structure borne sound. Cavity walls, compound walls may be used to increase the noise transmission loss. There is internal noise, noise that is produced in the hall or office inside, like for example, air conditioners, movement of the people, etc. So, the walls, floors and ceiling may be provided with enough sound absorbing materials. Gadgets or machinery should be placed on the sound absorbent material. Optimum value of reverberation time we have already discussed is around 0.55 for speech, and for music it is 1 to 2 seconds. Undesirable echoes that are produced, they should be avoided. Sound, as we have studied, reaches the listener directly as well as after reflection. So, a listener may receive sound which is in phase, then it will be constructive interference, and if it reaches the listener out of phase, then it is destructive interference. So, constructive interference is when the crest falls on the crest or trough falls on the trough, but if crest falls on the trough, that is destructive interference. So, this is how the sound waves travel. These are two waves. You see, if crest falls on crest, then it is constructive interference. If rarefaction falls on rarefaction, then also it is constructive interference. But if rarefaction falls on the compression, then it is destructive interference. So, if compression is on compression or rarefaction on rarefaction, then you have constructive interference, but if compression falls on rarefaction, then it is destructive interference. Also, if destructive interference occurs inside the hall at any point of the hall, then this region will not receive any sound, and we call it as silence zones. These silence zones, they should be avoided. These are the acoustical ceiling panels over the audience and over the stage. Ceiling clouds and panels produce balanced and blended sounds for a variety of venues. So, this results in a rich directed sound that the discriminating audiences have come to expect. The problems that we face during acoustical during acoustical designs is focusing of sound, echoes, shadows, resonances and external noise. So, this is how the chambers are constructed, so that there are no echoes or reverberation. The surfaces absorb all sound and reflect none. This is a fabric wrapped panel which provide good acoustical absorption. This is Decibel Concert Hall at University of Maryland College Park. This is another view of the same hall. This is the rear part. You see, these are all cushion chairs. This is the top. This is Tabby's recital hall. You see here that there is space in between the chairs. Path has been left out. The path is left near the walls also. This is another hall. This is Sydney Opera House Concert Hall building. Thank you.